To P or not to P. From dichotomous decisions to pattern recognition. Hello. For decades, classical statistics was dominated by dichotomous decision-making. Researchers typically framed their analyses around a simple question: should the null hypothesis be rejected? The outcome was often reduced to a binary conclusion: yes or no, significant or non-significant, reject or fail to reject. A p-value of 0.049 and a p-value of 0.051 could lead to completely different conclusions, even though the practical difference between the two results was negligible. As a result, generations of researchers became preoccupied with crossing arbitrary thresholds rather than understanding the underlying patterns in the data. To P or not to P, that's the question. However, real-world phenomena are rarely binary. Human behavior, consumer preferences, financial markets, biological systems, and social interactions are often characterized by complexity, uncertainty, and gradual transitions rather than sharp boundaries. Consequently, the field of data science and machine learning has shifted away from asking, "Is there an effect?" toward asking, "What patterns exist in the data?" Data visualization exemplifies this transition. When analysts create scatterplots, heat maps, network diagrams, or dashboards, they are not searching for a deterministic yes or no answer. Instead, they seek to uncover trends, clusters, anomalies, relationships, and emerging patterns. A scatterplot may reveal a nonlinear relationship that would be missed by a traditional hypothesis test. A heat map may identify seasonal fluctuations in customer demand. A network graph may expose hidden connections among individuals or organizations. In each case, the objective is exploration and discovery rather than binary decision-making. This emphasis on pattern recognition forms a natural bridge between data science and artificial intelligence. Indeed, AI can be viewed as an extension of the same intellectual tradition. Rather than being programmed with explicit rules, machine learning systems learn patterns directly from data. An image recognition model is not told what every cat looks like. It learns patterns associated with cats by analyzing millions of examples. Likewise, recommendation systems do not operate through rigid rules alone. Instead, they identify patterns in user behavior, purchase history, viewing habits, and social interactions to predict future preferences. The same principle underlies many modern AI applications. Fraud detection systems identify suspicious transaction patterns rather than relying solely on predefined rules. Medical AI systems detect subtle patterns in radiological images that may be difficult for humans to perceive. Large language models such as ChatGPT analyze statistical patterns among billions of words to generate coherent responses. In every case, the goal is not to produce a simple yes or no answer, but to recognize complex structures within vast amounts of data. This shift also changes the role of the analyst. Traditionally, analysts began with a hypothesis and then used statistical tests to confirm or reject it. Today, analysts often begin with data exploration, allowing patterns to emerge before formulating explanations. While hypothesis testing remains valuable, especially in experimental and causal research, it is no longer the sole paradigm guiding data analytics. Increasingly, discovery precedes confirmation. The movement from dichotomous decisions to pattern recognition represents one of the most significant intellectual shifts in the evolution of data science and artificial intelligence. It reflects a recognition that reality is often too complex to be reduced to binary outcomes. Instead of asking whether a phenomenon exists, modern analytics seeks to understand its shape, structure, dynamics, and relationships. In this sense, data visualization, data science, machine learning, and artificial intelligence are not separate disciplines but different manifestations of the same fundamental pursuit: finding meaningful patterns hidden within data. So, what do you think? As AI systems become increasingly adept at recognizing patterns that humans cannot easily detect, should we place greater trust in machine-generated insights? Or should human judgment remain the final arbiter of meaning and interpretation? I would love to hear your thoughts. Please leave a comment and join the conversation. Thank you for watching. Goodbye.